Hello, everybody, and welcome to our webinar about Dockerfile, where we have the pleasure that Bhushan is telling us, sharing some of his best practices with us. This is the first webinar of Uplink in cooperation with a freelancer of ours, and I'm really looking forward to. So for the people who don't know Uplink and who might be maybe just joined via a crowdcast, I will really shortly introduce Uplink and myself, and then we will talk with Bhushan and talk about the best practices of Docker. So Uplink, really short, is a network for IT freelancers and was founded by Manuel in 2016, who worked himself as a freelancer for more than 8 years, and he worked for startups and different agencies, bigger clients, like all the range you can basically work for as a freelancer. And then he decided to found Uplink as an alternative for classical IT recruiters. That means we offer like fair and transparent job placements and are more on the side of the freelancers. Exactly. So I'm really happy to welcome Bhushan. I will focus you as well. So, hi. So now people can see you. It would be nice
Hi.
if you shortly can introduce yourself, and then we can start with the webinar. I just want to say two technical things. So if anyone has problems about following the webinar, sometimes it might be a problem of your ad blocker. So you can just tell me in the chat besides. And also, if you have any questions while Bhushan is speaking, you can ask your questions down under in the toolbar via ask the questions, and then in the end, in the Q&A part, we will answer all your questions. I think that's the best choice, that we don't interrupt him. So now the stage is yours.
Oh, thanks, Mike. Hey, hello everyone. Thank you for joining for today's webinar on Dockerfile best practices. And I hope you know what Docker is already, and what is Dockerfile and the importance of Dockerfile in the whole Docker ecosystem. To tell you briefly, Dockerfile is a blueprint to create Docker images. And yeah, I'm Bhushan Lodha. I'm a senior software consultant based here in Berlin. Yeah, so we'll start with the Dockerfile best practices. So yeah, first of all, like why should I care about writing a good Dockerfile? I can just write a Dockerfile and then like create an image and pass it around. So the reason to write a good Docker file is because we want to reduce the size of the Docker image. With smaller images, they improve performance, they are efficient, and they improve security because it's a smaller attack surface. And the other area that we want to focus on is build time. We would like to reduce the build time that every time we build our Docker images, because it significantly affects our development cost. Because more often than not, when we are building, when we change the code and we build our Docker images, mostly like as a programmer, we are staring at the screen or like going around in the office for taking a coffee, and sometimes this can take 20 minutes. So this really adds up to the cost, and also on the CI/CD servers. So we also want our Docker images to be secure for obvious reasons, to not let any hacker to get access to our application or our machines. And we also want our image to be consistent, because consistent images are easier to maintain in future for you or any other developer who builds on top of your Docker file. Yeah, so we'll start with the first, reducing the image size. The first will be image variant. So most Docker files will start with a base image, and this base image can have a significant impact on the size of your image. So most languages or platforms offer three variants, which is the standard variant, which has all the packages, all the, yeah, and then there is a slimmer version which will not have the common packages, so you will have to manually install these packages, but it will reduce the size, so you only choose the packages that you need instead of like having the whole operating system. And then there is Alpine one. This is for Ruby. There is an Alpine one which is based on a different distribution on of Linux, and it considerably reduces the base image size. So yeah, so maybe the answer is obvious that you go with Alpine because it's only 52 MB instead of 149 MB or 842 MB of Debian. But that's not always the case. Like choosing the base image between Ubuntu or Debian or Alpine is like based on multiple factors. So primarily, Ubuntu or Debian is based on GNU C library. What that means it is like it has a wider variety of packages, and it is supported more. It has been worked by a bigger community. It has and Alpine is based on muscle libc, which will work for most of the cases, but then there are some packages which will not be supported. For example, Alpine doesn't support geolocation packages. So for that, you have to go to Debian. And also, like Alpine touts that they are more secure than Ubuntu and Debian. But that's not usually the case because Ubuntu and Debian, they have such a big community of developers behind it, so it is more battle tested. So for any serious application, I would advise to stick with the GNU C library implementation, then muscle C implementation. I mean, like remember, premature optimization is root of possibly all evil. So the second would be like we would not want to install the packages that we don't need for to run our application in production. Simple, like when you install packages with apt-get, it will also install some packages that are recommended to run your packages, but they're not necessarily needed. So simply adding no install recommends can reduce significantly the size of the image by removing the packages that we don't actually need. Then the other thing we can do is we can remove package manager cache, all the logs, all the docs, not just from package manager, but also your system docs or your system logs that you don't really need this to run your application in production. So I mean, the approach here should be to remove everything that you ultimately don't need to run your application in production server. So everything like documentation, manual man pages, yeah, and cache. Uh, then you can also remove your unnecessary files from the application. Like you don't really need your unit test files or integration files to run your production application. Once you compile your assets, you don't really need the asset files, so you can also remove those. You can remove your documentation. You can also, like when you install dependencies for your application specific dependencies, often they come with their own test files, with their own documentation. So this is something you can also get rid of. There's if your application has a cache, you should get rid of that. And usually your dependency manager will also have cache when you install your dependencies. So you can also get rid of that. This can easily also save around 50 MB of space. The next thing is like we can use multi-stage environment so you can have a stage to build your application, and then you can have another stage to run your application. So in this example, for example, in the first stage, builder stage, we are installing the packages and we are installing the dependencies. And in the second stage, release stage, what we are doing is uh, we are copying the artifacts from the earlier builder stage, which is install dependencies. Yeah, and this can can easily save. This can be a big space saver. In the example that I built, it bring down my image size from 674 MB to 300 MB approximately. Yeah, so there is more to multi-stage builds, but this is a topic, like there is so much more to multi-stage. But it can be covered in another webinar or something. But it's out of scope of this webinar. Then to reduce build time. So to reduce build time, what we will try to do is we will try to use build cache. Docker ships with a build caching mechanism, and we will like try to use it as good as possible. So the way build cache works for Docker is like each line in Docker is an instruction, and each instruction is cached. And when the content of an instruction changes, the cache for that instruction and all the subsequent instruction are invalidated. So what you really want to do here is you want to order your instructions from least to most frequently changing content. Like it's more likely that your code, your source code will change than the operating system packages. So yeah, you would want to copy your packages, your source code later, and then wherever possible, try to copy specific files. So in this example, if I copy all my source code, and then if I run my if I install my dependencies, and if I change anything in my source code which is not related to dependency, it will still invalidate all the dependency installation step, and then it will install the dependency again, which usually takes a lot of time, at least in Ruby applications. So what you would want to do here is copy specific file, which is like gem file in Ruby for installing dependencies, and like in the later stage in your code, copy the entire source code. Also, what you would want to do is you want to make units of your code that can be cached together. Like for example, here, the run apt-get update, it will create a layer and it will cache that layer, and after that, when you do install, it will create another layer and it will cache that layer. And it might happen that at one point, like your update is outdated, then install, but it will not update it. It will just use the cache. So to avoid these things, you would want to, like, also when you want to remove the package manager cache, you would want to do it in the same instruction. And yeah, use Buildkit. So Buildkit is a second generation image builder. I think it's available in Docker from Docker version 18. Among many other things, it supports parallel build execution. So it will build your stages concurrently, and it has a much better caching mechanism. It has much better garbage collection mechanism, and there are so many more features to it, which some of these are still experimental, and hopefully they will be tested and available soon. So the way parallel execution, so to enable Buildkit, you have to set the value of Docker Buildkit to 1 when you build the Docker image, or you can change your daemon configuration. You can set it in your daemon configuration as well. So yeah, the way the parallel build execution works is like, in this example, we have 3 stages, and in stage 3, we are copying artifacts from stage 1 and copying artifacts from stage 2. Stage 1 and 2 are not dependent on each other. So what Buildkit will do is it will make a dependency bottom-up dependency graph between your stages, and all the nodes that are on the same level will be executed parallelly. So in this with Buildkit, so stage 1 and stage 2 will be executed parallelly, which is concurrency. So, and then after that, the stage 3 will be implemented. And without Buildkit, which is like the old builder, like the current default builder in the Docker, it will be lexically executed. So which means like it will execute step one, stage one, then it will execute stage two, and then it will execute stage three. Now, in this case, we might have a stage four, which probably we don't need it for this build. So with Buildkit, it will not execute stage four, but without Buildkit, it will execute all the stages and then discard the stages that you don't need. This is a huge waste of time and space. So yeah, you can save this with using Buildkit. So how fast are we talking? So the performance benchmarking for Buildkit is like when you build the Docker image from scratch, it's at least 2.5 times faster than without Buildkit, than the traditional version of build. When you repeatedly build the same image without changing any code, because of the caching mechanism of the new Buildkit, it is 7 times faster than the traditional build that is shipped with the Docker. And when in the event when you change source code and when you build your image again, Buildkit still outperforms traditional builder by 2.5 times. So it's a really cool tool, and you can use Buildkit and Multistage to build different environments for your different for linting, for testing, for running integration test and unit test, and then you're not building the whole image again and only building the stages that you need. For security, you should always avoid running your application as a root user. So a lot of Docker files that I have seen is missing this. Like people are usually not adding user, and the root has like your application is running as a root. And what could happen is like an attacker could get a remote could execute scripts remotely from your application, and they can escape. There are mechanisms to escape the container environment and gain control of your machine, and this can cause much more damage as a root user if the application has a root privilege than as an unprivileged user. Also, when you are like adding a file to your Docker image, or you're copying files to Docker image, always copy them with the user and not with the root user. So if it is compromised, the damage is limited. Now, to build consistent images, you should always pin the base version of the image for any unexpected results in the end. Like, yeah, and always add Docker ignore file, like similar to Git ignore file. You can add Docker ignore file, which will ignore the folders and files that you don't want to commit in your Docker image, and this could like escape. You can escape like writing some sensitive information in your Docker image, final Docker image. Use official images when possible, and not just some random images that are maintained by random people. Yeah, like official images usually have a bigger community support, and they're more battle tested, and they're more consistent with their performance. And yeah, the last is like set locale. Always set. Some Linux distribution will not set locale by default, so you will have to set locale. You should. It's often overlooked. It's very important to set locale, at least in terms of Ruby on Rails application. This could, like, if you don't set locale, this could create problems with string encodings. Yeah, in presentation. So yeah, that's about it. It was short. These were the tips, and if you have any questions, you can ask. Now would be the good time.
Oh, I was muted. Yeah, definitely. So we have one question already, and if any of you have like further questions, don't hesitate to ask them. Though the first question is, why would you have different Docker images among your stages? Isn't the point to have the same application running on either stage? I think it refers to
Okay.
the beginning
Okay.
where you
So,
what?
uh, can you repeat the question again?
Yeah, sure. Why would you have different Docker images among your stages? Because the entities are it's a point to have the same application
Yeah.
running on either
Yeah.
stage, right?
So, uh, but like, what do you mean, base image or the final image that we produce?
That's a good question. Maybe you can specify a bit in the
Final
you
image.
just wrote like
Okay, yeah.
it's
So
about
it's very simple.
yeah.
So now, say you are running an application and you want to, in one of the steps in running an application is to compile your assets. Usually, at least in Ruby on Rails, compiling assets takes a lot of time. In some cases, it would take up to 4 to 15 seconds. Now, tell me, like when you are running your unit tests, do you really need your assets? Like, or when you are running linting on your code in the uh, in in the continuous testing step, if you are running linting, do you really need to install all the dependencies? You don't really need them, and so you can have different stages, which would like a stage. There would be a stage which will build your application, which will install all the dependencies, and there can be another stage to compile your assets. And when you are running unit tests, you can completely skip the test for compiling assets. So this is one advantage.
I see, I see. So I think now he got it. So you mean that it depends on your requirements on the quality assurance you pursue, right?
I didn't understand what that means, like quality assurance. Uh, what do you mean by that? Requirements
Maybe you
on
can
quality.
specify again, but 1 second. He made the point you made is good for unit tests,
Hmm.
but bad for E2E acceptance tests.
Yeah, which then in that step, you would like. So for me to run acceptance test, I would want to install few more tools on my operating system. For example, maybe I would need to install curl, and then I would probably have another stage which would do the acceptance test. The unit test was one example I gave. The another example I can give you is say when you are using uh, with this what is the tool called? Wiki to ST. Uh, okay. I will try to find the name of the tool. 1 second.
I think he got it. He just wrote.
Yeah. Okay. Any other question?
So far, there are like no questions. Did any of you? Yeah, Andreas just said like that Zoom might be better suited for a Q&A question. If any of one, I mean, if you more want to go in a discussion, at the moment we are just like 12 attendees. So maybe I can invite you on, if you're fine with that, I can also invite you on screen and then you can have more like a conversation. We could do that if anyone is up
Yeah.
for that. I don't mind. But we have another question. Do you have any tool to recommend for seeing the image size changing step after step while building it?
There is a tool. You can do Docker history. There is a command actually. Let me confirm the command Docker history. Yeah. So you can use this command Docker history and then name image. if you run this command, it will give you each instruction and the footprint, like the size it created from that instruction.
Okay, great.
So, for example, I can I put can I share a screenshot here?
Yeah, you can share your screen. Like at the moment, we're seeing your presentation, but if you
Okay.
so if
One.
you share it, I can focus it, and then the other can see it as well.
Wait, I can. Well, this is a bit high tech. I don't find option to share again, like stop sharing. Stop, and then share screen, share.
Oh wait,
Yeah,
this is a little issue.
yeah. So
But now it should work.
here,
It looks good. Yeah, I can focus it, and then
do you
second,
see my
everyone
screen?
can see it.
Do you see my screen?
Yeah, they can.
Yeah. So yeah, here. So I will clear this, and I would do usually Docker history and the name of my image. If I do this command, it gives me a detailed information of my command uh, and the size it took. Yeah, and it's from the most recent command to the last step command. Yeah.
Mhm. Great. So, any further questions?
Whoa.
Okay, I think we're good for now. I mean, if you also have I think maybe there is one. Let's see. But if you want to go in a discussion with that, you also can use, if you're already an uplink member, one of our um, channels, and we can get a bit deeper. Also, I will can share the presentation with you, and like I think around in 1 hour, I will just share the link in the chat with all of you, and then you can rewatch the webinar at any time anyway, but also can have again a look at the presentation. So thank you very much for your time, and see you all soon.
Well,
Bye.
thanks for joining.